basically here, the goal is to show you, give you summaries of the tools, and then the symbols we're going to use, and for the transformations. And so here we're starting from is I introduce a directional cosine. And kind of step by step, and kind of leading you to the notations. So if we consider given coordinate systems, so let me say this is the 1, 2, 3 coordinate systems, okay? And in each coordinate system, we have a unit vectors. So this is the unit vectors. Okay, and what kind of the labels I'm going to use it, and later on once we use it, I will give a labels. Okay, so now if we consider a vectors, so here we given coordinate systems with the unit vectors 1, I, j, k. Okay, so here let me say this is the I, j, k. Okay. And then we also consider vector, any vectors. How about I prime? And I prime could be the any vectors. Okay, so so here I prime is a unit vector, can be a vector. So I would say consider a unit vectors. Let me be more specific. And let me project these unit vectors. I want to express I from into what kind of the I vectors, and what kind of the j vectors, and what kind of the k vectors. I want to find the coordinates of these given vectors in the given coordinate systems. And the way we can try is this, and let me do it graphically. Let me project. Okay, so from here you can clearly see the coordinates simply is the projections into each systems, into each axis. So say, let me define this as the angle alpha. So can you tell this one is the projections, this is the length, is a projection between the I-axis and I, so that is a cosine I. Now, so this one is I prime project onto I, right? All right? Again, let me use color. How about that? So this is the amount that represent is the projection of these vectors into one direction. Sorry, not to this one. So this amount is the projections of the vectors into one direction. So in terms of the inner product that represent is this one, right? Okay, and also the two are unit vectors. Basically, that one, if the angle is alpha, so that is also called cosine alpha. Okay. So here, this one, the first quantity is simply cosine alpha. The same thing. This is the projections of these vectors into two directions. So that is this amount. So this one is simply is these vectors projecting onto the j directions. Okay, this is j direction, and then you assume this given the angle, this is beta. So basically, this one is also in the product is cosine beta. Okay, so the cosine beta represent is the amount of the projection into the two directions. So this is cosine beta. And then the last one is this. So that's the projections into the third direction. So that is I prime and projects into the k directions. So k. And again, let me call this is gamma. So this one can be calculated by cosine gamma. So here this is cosine gamma. Okay. So therefore, for individual one, those one are called the directional cosine. Cosine alpha, cosine beta, cosine gamma, they call the directional cosines. Why they are cosines and why they call the directional? Because they are used as the components to define the directions of one vector. Okay, so that's the origin of these definitions. And then we consider the coordinate systems. So this is 1, 2, 3, and say this is ijk. Okay, the same thing before. And now if we're going to transform the 1, 2, 3 into the different orientations, so let me say this is 1 prime, 2 prime, 3 prime. Okay, so that means in individual direction we have I prime, we have J prime, and we have K prime, the unit vectors. Okay, so here we between two coordinate systems, 1, 2, 3, and 1, 2, 3. Okay. So here we can do this. Right now we already have this formula. Okay. So let me say for the 1 prime axis, we copy this formula. That is cosine alpha, cosine beta, cosine gamma in ijk in ijk coordinate systems. Okay, and be specific, and let me say this is alpha 1 and beta 1 and gamma 1. Okay, so similarly, and for J prime we have the same patterns, alpha 2, beta 2, gamma 2 in ijk. Okay. So these basically the 1, 2, 3 equations constitute the rule for transforming the coordinate systems. So if we know the so here if we are given the 1, 2, 3, and also we know the alpha 1, beta 1, gamma 1. Alpha 2, beta 2, gamma 2, and alpha 3, beta 3, gamma 3, etc. Then we can apply the rules, we can do the transformations. And here I will come up with a more systematic way and easier way of adopting the notations for you. So here is we can get these 3 equations put into this format. So here is the format like this. I'm going to write into a matrix. Okay, so for the first equation, that simply is cosine alpha 1 times I, cosine beta, cosine gamma. So put into matrix, this should be cosine alpha 1, cosine beta 1, and cosine gamma 1, right? For the matrix calculation, say AB equal to, say, let me put any numbers, C1, C2, D1, D2 times AB. So you know the A, that meaning A equal to the row multiplied this column equal to C1A1, C1A plus C2B, right? And B is equal to D1, this row, multiplied with this column, so that is D1A plus D2B. So that is the operation of the matrix. So the same thing, I simply rewrite these equations. So basically the second equations for J, that is cosine alpha 2, cosine beta 2, cosine gamma 2. For the third equations, cosine alpha 3, cosine beta 3, cosine gamma 3. We good? So for this case, let me define what are given, what could you find. So here basically is this. We are given the coordinate systems I, J, K, which means the 1, 2, 3, okay, and that means the 1, 2, 3 here, okay. And also we are given alpha 1, alpha 2, alpha 3, beta 1, beta 2, and beta 3, gamma 1, gamma 2, and gamma 3. So that means we are given, we know the relative configurations between the two coordinate systems. We know how they relatively respect to each other. We know that the relative orientations given to this one. So we're going to find the coordinate in 1, 2, 3 prime. Okay, so that is our problem statement. Okay, so that is the answer. Okay, and most of the time, this one is a little bit hard to, I would say, to memorize. Okay, so here is my notations. Basically here we define this one. This is defined as the R. R is called the matrix of transformation, or simply it's called the transformation matrix. Okay, so sometimes we simply write it up as I prime, J prime, K prime equal to R times I, J, K. Okay, the vectors. So that is one. A better way for that at least worked for me for many years is this. I simply put it into this kind of tables. And this one I put the I, J, K, and that is the old, I would say old is the given. Okay? And here I put is a new. That means it's the transformed coordinate systems. So that I put a new. Okay. So simply into this table, you simply put into is cosine alpha, cosine beta 1, cosine gamma 1. Okay. And cosine alpha 2, cosine beta 2, cosine gamma 2, cosine alpha 3, cosine beta 3, cosine gamma 3. Okay, and a lot of writings, right? So many times the people like to use symbols. So for example, here for easy writing, if you like, you can say put into this. This is simply L, I, and M, J plus N, K. Okay, simply use L and M. So let me utilize the L and M to kind of have a rest or muscles here. So basically change the symbols, say cosine alpha 1. Basically that one using the different symbols for directional cosine. This is I, J, K, and out for the new I prime, J prime, K prime. So L1, 2, 3. Okay, I simply changed the replace. So let me call this is the L1. This is called the M1 and M1, etc. So this one is L2, M2, N2, L3, M3, N3. Whatever the notations you like, you just put in. So basically, this is our matrix. Okay. So we have these tools, and how can we utilize the things? This one is tell us the transformation of the base vectors. Okay, the base vectors, and so that is the one to the node 2. Okay, and then I'm going to go to the node 3. And once later we have calculated, maybe I can give a quick example here. So we can try this one. Many times we can simply observe the components, and here I show you a very quick, easy calculation, the symbol. So this is x, y, considered two-dimensional. And say that we transform into x prime and y prime, and z, basically this rotation is about 30 degrees about the z-axis. Okay, z-axis is here. Okay, so again, and let me say the unit vectors here is I and J, and then into the new quantum system, let me call the I prime and J prime. Those ones are the unit vectors. Okay. So here we can build up this table quickly, and you simply look at here. So this is our given. So that is I, J, K, and there's a transformed I prime, J prime, K prime. And here, this example, I just simply want to show you how to determine the components. So from here you can see, for given, this is I, this is J, and I prime is here. Right? We simply do the graphical projections. This is 30 degrees. So from here you can easily calculate how much is this one. So this one is cosine theta, right? And how about this one? That is sine theta. So 2 square 3 of 2 in the I directions. So for I prime, that is this one in I direction, we have this magnitude, so square 3 over 2 put here. And this is the amount in the Z direction, so that's the 1/2 put here. And this one has no projection into the outer board, so this one is 0. So many times for this kind of Cartesian quantum systems, we can observe. We don't need to go to the very detailed. There is only for symbols. Okay, for J prime, the same thing here. and this is J prime. Okay, the same thing, we simply project. Okay, so this quantity, if we look at here, this is 30 degrees. So that is cosine 30 degrees. So that is square 3 over 2. And this one is the component in the Z direction. So 3 over 2. Okay. And this quantity is sine 30 degrees, and that is 1/2. And however, that is the directional, so that is pointing to negative I direction. So here we should be putting to negative, and the magnitude is 1/2. Are we good? And no projection is 0. Okay. Now we come to the Z direction. The Z direction basically this prime, sorry. The Z prime basically K equal to K prime. So K equal to K prime. So it's 0, 0, 1. So using this example, we can quickly build up the content. And here, those symbols, forget it. Those ones just for introducing the definition and concepts. Okay? Maybe today we stop here, and I will continue maybe using another about half hour to make a few more notes. So for this section, we have, in my lecture notes, I have 5 or 6 notes, and I will complete that one next time. So, by the way, got it. So do you know